All right. Unless I messed up, we're live.
We are live. Good evening, everybody. Hopefully,
Howdy.
there's some people here. Yeah, we got 21 in there. That's good. It's always
Yeah, we
great
don't
to have
have
a
Randy
live.
today.
It's always great to have a live stream and nobody be at the live stream.
All right.
All right. It says we're on, but welcome everybody tonight. Ape and I are going to go through. We're coming up with a new antenna for Coffee and Ham radios, and we're trying to offer something it's kind of out there already, but the stuff that's out there is like hundreds of dollars, like $500 for kits sometimes to have a multi-band vertical.
Mm-hmm.
And there's going to be some losses and stuff, and that's what we're going to do tonight is see what losses are. I already know that the one of the popular ones is like a 5-to-1, and they're 5-to-1's pretty lossy. I don't
Well,
know,
the
but
thing is that like what you don't see is antenna manufacturers show the data on just how
right,
lossy their antennas are,
that's
and
right.
they use marketing words. Mark is saying audio has a lot of reverb and echo. I'm not hearing anything. Are you?
I'm not hearing any either.
I can.
What he's talking about. Maybe
Yeah, I mean, I
it's
don't
I
know
don't
what
I don't hear anything, and I usually hear it if we have it.
I don't know, Mark. You might need to check your stuff. But James is in the chat and he says we sound okay. But see, a lot of these antenna manufacturers, and we're not trying to bust on them because they do a good
Right.
service for us as hams, right? But
Oh yeah.
they don't show a lot of the data around how their antenna performs. And what they'll typically show is like an SWR chart, like for how the antenna is
Right.
performs in a certain type of setup and configuration. If you start modifying it, then that goes out the window. And then they may
Right.
show gain numbers like dBi or dBd. They'll typically show dBi because dBi is higher than dBd.
Right. Exactly.
And what they'll do is they'll show those gain figures, and they're really only talking about the takeoff angle with the greatest amount of gain. They don't show far field plots.
Mm-hmm.
And so we want to be completely transparent with everything and show all of that testing, all the work that we've done, all the modeling that we've done. And then that way folks can make I do have a cold, Lee. They can make an informed decision and really understand, hey, this is a kit and how I put it together is going to impact that. And because it's a modular style kit, I can have some control over how my antenna performs. And we want to show how we do all the different testing so folks can do that and then build it to fit their needs and their operating style.
Right. And one of the nice things about this antenna, it doesn't take up much space, and
No.
it's not super tall, so it's easy to get it at its height and all that stuff. And then you just have some radios, some ground radios you have to put down. And technically, it only calls for one, but we're gonna actually sell. The kit's gonna come with enough wire to do like 4 of them that are 17 feet, and probably some little extra after that.
And if you want to do 8 at 8 feet, then do 8 at 8 feet, right? We'll show you how we figured out what we wanted to do, and we're just about done, right, with all the testing.
It is. We're actually waiting on wire. Our wire's due here towards the end of the month, and then this thing will be on the market.
Yeah, and some instructions. We're waiting on instructions.
Yeah, instructions. I've got a list started too of all the parts. So I've been testing it myself on the air, and it does what it's supposed to do. I talked to a group of guys in San Diego, and my doublet is better than it to San Diego for that distance, but it should be. And in any kind of antenna that I've used a half square before, and same thing with that. But it's because of takeoff angle, though, because it's a lower takeoff angle, and it's not good for that short of a distance.
The thing is that when you look at an antenna like this, so this is a multi-band vertical antenna that's only 25 feet high. So you're compromising 25 feet high antenna because we want to do that to make it easy to deploy, get on the air quick. It's not going to perform as well as like a 43-foot vertical on 40 meters or anything like that because it's a smaller antenna. Right. And the other one is that because it's multi-banded, you have some compromise there as well. But I think it's going to be a fun antenna.
I think soda guys might like this if they've got something that's fairly compact to put it up with, or a tree that they can throw it in, and like with the KX2 or something like that. because I've already done that and it worked pretty well. I did the video on that a while back, and I was only out there for half an hour and made about 20 contacts on 10 watts. So it worked.
So Matt here saying he's looking forward to the 2-meter antenna. And we got to get back after that, being honest with you, Matt. So you're the second person today to say that to me.
And it's ready. I've reworked some stuff on that, and I wasn't happy with the SWR to start with, and I rebuilt everything, and I've got it to where it's pretty good now. That the one thing I'm using it on a aluminum pole, and on the FM, if you have it vertical, it does affect it. I have to get it raised away from that a little bit, but other than that,
metal poles will get you every time.
Yep.
Don says part of his ceiling collapsed. You need some duct tape, son.
What? His ceiling?
I didn't know he was having problems there. Good luck with that.
I didn't either. Good luck there.
I guess they got a bunch of snow down there, didn't they?
Oh, I don't know. I've been busy getting everything ready to go down to Quartz Fest, and been loading stuff kind of on and off when it doesn't rain. It's been raining here in fact, the day I leave, it's supposed to rain for like almost a week here, so I'll be getting away from the rain.
Don saying he posted in Discord. Ain't nobody got time for Discord. Listen, man, I was on vacation last week and I came home sick, and I've been trying, just between work and laying in bed. I'm the biggest baby in the world, right? So when I get sick, I'm like, woe is me. I'm dying. The Lord's coming to take me home, and I'm probably not as sick as I make it out to be, but I feel terrible. And so I'm gonna milk it for everything it's worth. What do you think of that?
Yeah, why not? Liberty's saying it's supposed to rain on us at Quartz Fest. I haven't checked the weather there yet.
Texas ain't built for the cold weather, I guess.
We better make sure we stay away from the. We don't park in any of the river, the dry riverbeds.
All right, well, let's get to this thing and start talking about it. Okay. So, hold on a second. We got Doc Brad in here.
Hey, Doc. Thanks, Doc. Appreciate it.
Thanks, Doc Brad. And let me see. I think I probably got something here we can play in celebration of that.
All right, rattles your teeth. Thanks, Doc. Appreciate it.
Yeah, it's Cliff is saying hot toddy time. I'll tell you what, after the show, I'm going to go drink a glass of turkey, a nice big 8-ounce glass of wild turkey. And so either I'll feel better or pass out.
After our DMR the other night, I told my wife, I got to have a beer. So I got a beer, and then I fell asleep. I ate dinner and fell asleep, and then never drank my beer. I ate about half of it, so that was kind of wasteful.
All right, so let me see if I can figure out how to do this. You'll make me bigger as I switch my camera.
I will do that.
I think that's what I want to do. So there's a bunch of Toroids, and so I want to talk a little bit about what's at the heart of the antenna. And so this is it.
Let's go through the process, because I've tested multiple ones.
Yeah. So
this is what we're kind of finalizing with.
So what this is it's a 4-to-1 un. And so I recently did a video showing the differences between a 4-to-1 Balun and a 4-to-1 un.
Mm-hmm.
And this is those on the cores that we use for the Apollo. And a lot of people make a big deal about the types of cores and what you should be using and what you shouldn't be using. And the antenna, we call it a Poseidon, right? And let's see if I can do this and then do this. And we call it a Poseidon antenna because it's kind of like our take on the Rybakov. And so Rybakov is a Russian antenna, and it's Rybakov.
It's an Italian antenna. Antenna. But
I thought the word named after a Russian.
It was an Italian guy that invented it, but then it was named after the Russian thing for some reason. There's a whole story around the whole thing.
Yeah, but it means the fisherman or fisherman. And so we name all our antennas after Greek mythology. So we decided to go with Poseidon being the Greek god of the ocean.
I didn't see the fight this time between you and Jim on this.
No. And the thing is like for a lot of these antennas, they're using powdered iron cores. And So we looked at a couple of different powdered iron cores and went with one that Chuck actually had, and Chuck and I were going back and forth. I'm like, Chuck, ain't nobody ever heard of a green Toroid? And
I just happen to have them here. I've got
and
another
we
one.
tested them out, and so far completely happy with the performance. But we just talk a little bit about what it is. So when the type of core that you use is going to impact an antenna's broadband capability for transformation. The number of wrappings will also impact the types of the amount of transformation that you get, and the amount of wrappings will increase or decrease efficiency. So there's a couple of different things that and even the size of the wire, and then even the type of the wire. So like for our 9-to-1, we use an insulated copper core wire. This is a magnet wire, which does have insulation on it, but this is a magnet wire that we use at 18 gauge. And we do 8 windings. And the reason I'm using the red one is just it's easier to see. And so we do 8 wraps, 2 wires at 16 turns through the core. And then what we do is we connect the inner strands together. And then we have what's called a center tap that comes off of this. So this is the exact center of the core. And then each one of these legs does something. One of these goes to ground, and one of these is your element or your aerial. Now, depending upon what you do with this center tap, like for ours, because we wanted an un, the center tap is going to go to the center conductor, and then our ground is going to go directly to the shield of the coaxial cable. That's the difference between an un and a balun. A balun does it differently. A balun, the center tap goes to the shield, and then the direct connection is to the center core. So we do it a little bit. We do an un because we're using coaxial cable, which is unbalanced, and our antenna being a vertical is unbalanced. And then we do add the counterpoises, but it's still an unbalanced antenna, i.e., it's not symmetrical. Here we go. Don's got something. He says, "How many of those windings do you have to do before you don't have to follow the drawing?" Because I know I'm not there yet. You know what? I got to be honest with you, Don. I look at the drawings a lot because I just want to make sure that I get it right. Yeah, because the thing is that once you start running, like, these are almost the exact same thing, right? A balun and an un. But once you do so many of them, you start to forget, oh, this one goes this way or this one goes that way. Now, 49-to-1s, I can do that all night long without a chart. But the 9-to-1s, in particular, I always look at the chart.
Yeah. And I actually wound the red ones around the 43s. The red one worked. That was the one I took to on one of the POTAs, 100-watt POTA, the one where I got the guy in Ireland.
Right.
But the problem with that one, your internal 3-to-1 will not tune all the bands with that one. The one we're using, and that's kind of what we, Ape had to test it, make sure it was efficient enough. But the one we're using, you can do 80 to 6. At least I can at my house. Now, I'm going to try this thing down at Quartzfest and see if it changes. It may change on different ground, and I'm pretty sure Quartzfest is probably the worst ground I can put it over, right? The desert.
Yeah, probably. We can look at the USGS map and kind of understand that. But the thing is that, like, we're saying this is a 40 to 6, and depending upon your setup, you may need to use an external tuner or not. Like if you have a G90, you should be fine. But in some cases, depending upon ground and how you have it mounted and all that, you may need an external tuner. So the first thing we do is we test its ability to do impedance transformation, and we'll hook this up and do that. And what I do is I simulate a 200 ohm antenna hooked to the antenna line right here. And then I just put these are each 100 ohms, and I put them in series, and then I tie it down to the ground. Now in our antenna, and we'll show you pictures later, we hook a counterpoise to this ground as well. So you'll be able to see that. Before I do all that, I wanted to show a quick picture. Let me move this so I can do that, because people are like, well, how do you get to the 1-to-1 and the 2-to-1 and all that stuff? And so here's a schematic that shows the core that we have. And so if you remember, here's our center winding right here. I was just showing you on the core. So let me show you right here. This is our center tap. So our center tap comes out and it goes right here to the center conductor of our coaxial cable. And then I was mentioning that this is the ground of the antenna. Probably drew that all goofy. And then that comes out and goes to the
there you go.
to the shield of our coaxial cable. So this is directly connected. This is the same case with 9-to-1s as well. And so one of the things that drives me bonkers is people are like, you don't need no counterpoise with no 9-to-1, 4-to-1. So with an unknown design like this, there's zero choking that takes place on your ground connection. So when you send a signal out and it goes this way out your antenna, because we're using differential mode current or AC current, there's definitely currents that come back and they seek a path to ground. Without this, that 100% is going into your shack in the form of CMC, right? And we don't want CMC on people's stuff. So our recommendation is put a counterpoise right here off of this one. And the other thing that we want to do is we want to say, use a choke. You're going to want to use a choke with this behind your antenna feed point.
In all my testing, I've used a choke at the feed point of the antenna where the coax hooks up.
So if we take a look at this right here, this is the two different wires that we have wound around our core, right? And so this one is our primary winding, which considers 8 turns, right? Because we wrap the wires 8 times. And then this one here, this is our secondary, which is 16 turns. Hopefully everybody can see that okay. So if we do a little bit of math real quick, if we take 16 and we divide it by 8, we get 2. Right? That's our magic number. 2 squared equals 4. And that gives us our 4-to-1 impedance transformation. And that's how that works. Now, I get that one over that pretty quick. But I just wanted to kind of explain, because I've seen some other people who like to say that they're antenna designers, not explain that correctly to folks. And I just wanted folks to understand that.
I did have to check Ape on his math one night on this. He came up with 7-to-1 somehow.
So I wanted to,
weird.
Yeah. And so what I wanted to do
night
is just cover that so folks understand the primary versus secondary. And you can do different windings, right? So if you did 10 windings on this, you would have 5 on your primary and then 10 on the secondary. 10 divided by 5 is 2. And you would still get 4-to-1 impedance transformation, but you would likely get different performance out of the core. So hopefully that covers that piece for everybody. And I guess real quick, what we can do is I've got my handy dandy nano VNA here, and I'm just going to hook this one up and run a quick SWR test on it. So when we do this test, what we're doing is we're testing the core's ability to transform the 200 ohms from our load down to 50 ohms, which is our system's impedance, because that's what ham radios use. Exactly like an auto transformer mic, exactly like that. So let me go back over to OBS, and then let me do this, and let me turn this window on. All right, so right now, I didn't switch it over. So much stuff, and I'm not good at it.
So Lee was talking. He doesn't have a tuner on his portable radio, but this thing is actually on some bands. I think if I remember right, on 10 meters, it's totally usable. It's under 3-to-1 on some of the bands, so it still may work for you.
And you may be able to just play with the length of the element, right, and get to where you want to be on that. So here's nano VNA saver, and then let me do this. Turn me off. All right.
You want to take me out of there too?
We can do that. Let's do this.
There you go.
And then so what we're just doing here is a sweep from 6.5 megahertz, so just below the 40 meter band. And then we're doing it up to 30 megahertz. And what I'm going to do is I'm just going to run the sweep right now, and let me change my chart. Let it run, and then we'll change the chart. Oops. I wanted to set this for 10 segments. And the display setup, we want to look at VSWR. So let me just go ahead and run the sweep. And so when the sweep runs, what we can see is that our marker number 1, I'm just going to move it over here into the 77 megahertz. And the SWR is 1.35. So that's doable. And remember, this is against a 200 ohm load. The actual wire is going to be different depending upon the other factors that we already mentioned. Marker number 2, I just moved that down into the 20 meter band. And if I look over here, our SWR is 1.2 to 1, which is pretty good. And if I take marker number 3 and I move it down into the 10-meter band, we are at 1.18. So in terms of impedance transformation, the core is doing its job, and we feel pretty good about that.
Yeah.
I don't know if anybody's got any questions or
comments
or concerns about
this is pretty much what I'm seeing actual too when I'm out testing it. So my 710 and my 991, I tested it with that one too. We'll actually tune it 1-to-1. So it's been really good. And I was sitting here one morning, early in the morning. I had it set up for about a week out in the backyard, and I've got a bunch of guys with big Yagis, and they're beaming long path to Africa and stuff. And I would not been able to talk to anybody, but I was actually hearing the people on this antenna. I was hearing them on my doublet also. They were pretty comparable at long distance. I mean, and I was probably not going long path, so I was just listening. It was out of band for me, so I couldn't talk anyhow. But I mean, if I run enough power through it, somebody may have heard me, but I don't think I can do that. So, but what is Don? How well does that work on? I don't know what he's saying.
220 or
220,
2200, I should say. Hey, Arthur, how you doing, buddy?
And I was able to tune it up on 6-meter also. Of course, I couldn't make any contacts there.
So here's some modeling that we did in MMANA. I think you say it, Gal. MMANA, Gal. And I'm not the world's greatest antenna modeler in that tool, and but I think this is pretty good. There's one thing I want to try differently, and that's the way that I constructed the ground radials in the model. So I may want to change it a little bit. And this is the far field plots for 10 meters, the down through 40 meters. And like the green line is 10. So this chart down here kind of shows, thanks, David. This green is for 10 meters, and it corresponds with the legend at the bottom. We did a 28.3. And it's almost diamond pattern, which is really crazy. So like that follows the 4 counterpoises that we have that go north, south, east, and west. So you can see their impact there. When you look at 15, 20, and 30 and 40, all of those pretty similar from a gain standpoint. You can see that in the downward projection on the left. If you look at the projection on the right, you can see a little bit of performance difference there. And actually looks like 15 is actually the best in terms of takeoff angle, if you're operating at 15 meters.
Yeah,
we just kind of want to share that so folks can get an idea of what to expect from the antenna. Now it doesn't have as much gain as something like it's lower gain than a dipole. Not much, but it's lower.
But a lot of these antennas are. I mean, that's
yeah.
They're good for certain things. Like this one will be good for if you don't have any. Say if you're an HOA, this actually might work for you because it's only 25 feet if you can get it up, if hang it out of a tree, if you have a tree. And what I do is, and we're not talking bad about Don here, but you don't want to use this on a graphite pole or a metal pole. Use a fiberglass pole or a tree.
Carbon fiber.
Carbon fiber, yes, because that will affect things. Even if you can get it, I just saw something, I forget where I saw that, but even if you can get it to tune up, it's still going to mess up your patterns. Okay. So we're not hitting on carbon fibers are great. I'm going to use one this weekend for certain things, but not for everything, not for verticals.
Yeah. Don's asking why 10 looks like NVIS. And so if you take a look at 10 on the lower takeoff angle, it's better than every band except for 15. So it's better than 20 and 40. But you do have these pretty high lobes that go up pretty steep there. I don't have a good explanation for that other than I believe it's the ground radials doing that. And so that's why I said I want to do some more playing with the model here just to make sure that I got the radial set up correctly. But this is what it's looking like for us.
Mm-hmm.
And again, we want to just share the stuff to be totally transparent. The 10 meters has the most gain at about a 45-degree takeoff angle, which You went the most gain for NVIS at like 85 to 90% takeoff angle. So it's not quite NVIS, but that sure does look cloud warmer to me, right?
Yeah. Well, what I'm noticing is signals back to me are higher than I'm giving back to them. So it seems to get out better than I'm hearing is what I'm seeing so far. I get a lot of like, you're the loudest signal on. One night, some guys like, you're the loudest signal on the band, and I was like, well, that's surprising, but because of what I was on, but because I didn't expect that. I don't know. It's just one of those things. Every antenna has its good things and bad things, and I think this one, I tell you, this is something that I will probably use off and on with my Elecraft KX2 because it'll easily tune this thing and it should have good takeoff angle. I don't get a lot of people in California to start with on 40 and stuff like that when I do a POTA. So
you're just saying you could change it quite a bit if you raise the radials. Yeah, and so for the model, I've got them 0.05 off the ground because I think it was the lowest I could get it.
Mm-hmm.
I don't disagree, Jeff. Raised radials, obviously, if you tune them, you get it changes everything. Hey, and
it does.
We don't want to get in the business of tuned radials just because they're a pain in the ass. That adds time to deploy time. And then this is Chuck built one as a prototype. We're not going to say anything about his cold solder joints because he gets sensitive about that. Which I don't know if you wanted to talk about this at all.
This thing is pieced together. It's been in like 3 different things here, so it's kind of just pieced together. It's not. I mean, I had it in a different. I had a different winder, but I'd say this is one of the easiest antennas to wind. It's not very hard. I do both at the same time, and I use little small zip ties, not like the big ones that Ape was using there. And a lot of times, once I get things hooked up, some of those will come off, and then I'll just use the ones that are going to tie it down. Those are just aiding you to not lose the thing when you're wrapping it. This is, I'll tell you what, this is the Toroids we bought even look better. I mean, they're really nice looking Toroids. We had a hard time finding these. I came up with these, and then we couldn't find them.
Yeah, so we're only going to have 50 units.
We're going to sell 50 the first 10, and I think the place had more, but not a whole lot more. So it's maybe a short run antenna for now.
Yeah, Cliff said, yeah, because we got to see how folks like them and stuff too. And if somebody buys one and you have problems with it, reach out to us and we'll help you see. We'll get it right, no matter what we got to do.
Yeah.
And of all the other antennas we sold, we've never had anybody want to return one. And anybody who's had a problem has been a construction problem that we've been able to work with them and get through it. Yeah. And the feedback that we always get is, hey, this thing works great. So we don't want this one to be a stinker, right? So that's why we're spending a lot of time working on it. Cliff is saying that he thought 10 wasn't good for that sort of thing. Doesn't it go through the stratosphere? It does. So as always, you want to consult with the muff map and see what the muff is in your area if 10's running well. And as I mentioned, when we looked at the far field plot, the takeoff angle of greatest gain was at 45 degrees, which is not an NVIS angle. Like NVIS is like 85% takeoff angle. So it should be fine. It's not an NVIS antenna. It's a vertical antenna, right? And so the thing is that vertical antennas are not NVIS antennas by design. So it's not something that we would say that. That said, there's a lot of gain going up, and we believe that's because of the ground radials. And like I said, we're still working on the modeling. That may change a little bit.
So I've had fairly good luck with it. I haven't used it a ton. I've done it on. Well, I did the red one on a activation, and I did an activation at 10 watts on the green one, and it worked. It worked really well. I was actually getting pretty good. Like I said, I get better signal back than I'm giving usually. And I don't know if people are using their. Sometimes people use the amps, the preamps and stuff.
Yeah. So, Doug's saying a V configuration seems to act like a vertical. They can, depending upon how tight your V is. Like if it's more than 90 degrees, then it starts to really act more omnidirectional, like a vertical. So the thing is that with this antenna, you can mount it as an inverted V, you could mount it as a sloper, you could mount it as an inverted L, you could do whatever you want with it. we're only modeling it as a vertical because that's our recommended use case. But like I mentioned earlier, given the component nature of these and that they're kits, and with our other antennas, we've seen people do all kinds of crazy stuff with them, and we 100% expect to see that with this one as well.
Right. And I think these type of antennas have been pretty much into the. A lot of people. Mike has been using it. I think he's been doing it back in New York there. And tell you the truth, if you live on the East Coast, it might be a good antenna to get some DX.
Yeah, Don, I think he's being coy, but he's asking if you can mount it as a half square. It'd be an awful small half square because it's only 25-foot vertical. But sure, why not?
Yeah, I got my half square packed up. I don't know if I'll put it up for 20.
Yeah, we've been getting some good muff these days, Paul. I'm right there with you, bro. All right, I'm going to move over to the next picture, Chuck, and I believe the next picture is another one of yours. This is an early prototype that you put together there.
Yeah, that's what I said. This has been on a bunch of different winders.
I can't believe there's no Smokin Ape sticker on that pole.
There is, I think, but you just can't see it there. And another thing is, I went through. I spent one day wrapping and what I did is I started with a bunch of wraps and I just kept peeling them off until we got to the one that seemed to be the best. And I'm sending Ape all my, he doesn't really like the rig expert, but I'm sending him rig expert pictures, and he goes, "Oh, that one looks better," and we finally went with the 8, and then he tested the 8, and it's pretty good.
Yeah, so when we take a look at this, a couple things I wanted to mention there. You notice that Chuck's got a choke right behind, and so that is the recommended mount, right? Doug, how dare you? The recommended thing is to put that on there. Lee's asking how far off the ground should the transformer be. I would have it about a foot off the ground.
Yeah, this one was higher than most. Most of the time, I've got it about a foot, just so I can get a nice little angle on my my choke there. If you get it too close to the ground, that choke doesn't like it.
Yeah, what you got to remember though is we're testing everything that we can think about, right? Because we want to.
And if you look at
one, to handle questions and make sure it works right.
Where I had it set up here, I couldn't even get a good pattern around. And I think I see 1, 2, 3, 4. I had 6 on this one. We've changed that back to 4.
You got 5. Oh, is it 6? Yeah,
I think there's 6 on there.
And the other thing is that so Chuck, talk a little bit about the Velcro strap, and that's how we're going to suggest people mount them to the poles too.
Yeah, our antenna, all of our antennas ship with the same Velcro strap, and it works fine. It would even Ape was asking me about the spider beam poles. The 10-meter spider beam pole is a lot bigger around the bottom. I think it'll still make it around that one also. So, and that's all I do. And what I do is I pull just a little bit of tension on the top because I'm not at the very tip of this antenna. It's like 2 or 3 in. I forget exactly where it's at. So I can get a little bend at the top. So it keeps the antenna, the wire nice and taut. And, I don't pull it down too hard. It's where I'd break something, but, it looks like it looks like I caught a fish on it. Usually it's got a little bend in the end of the pole there. And I've been running about, I think 50 feet. I ran 100-foot section of coax because I actually brought it into my house for a while so I didn't have to sit out in the cold. I was doing this thing late at night one night. I was freezing out there, man. It was like 8 o'clock at night or 6 o'clock. Well, 6 o'clock at night, but it was already dark.
I'm just messing with stuff on my desk. I know it look weird.
And when I set it the last time, I set it more to the middle of my yard so I could actually spread my radios out more evenly, and that seemed to be nice. I don't personally. I mean, talk to the DX commander. He's like, you just put them out wherever you can get them. This would be a pretty good. This would be a pretty good antenna if you had a tree in your backyard and you could hang it. If you're an HOA or something, probably, and what I would do if I did that, I would just have like a stake in the ground and tie it down to the stake, maybe with a little bungee cord or something. Like
yeah, you could do that.
Just so it'd have a little bit of spring to it, especially if you're in a tree.
Well, the frame's got lots of different mounting holes, right, to give you those options.
Yeah, you've got holes in those, and I've done that before. I got those little 6-inch, like 1/4-inch bungee cords with the clips on them. And I've clipped it on both and stuck it around a a pole or something just to hold our winders on different antennas that I've used of ours. That's the reason we put all the different holes in this thing. It's our winder. This is our winder, except this one I printed. I think this is actually the QRP size, actually.
All right, I am going to go ahead and I am going to stop sharing. Boom. That's all the pictures that I had.
Did you have the? I thought you did the efficiency stuff on what the efficiency was or something.
We're fixing to do that right now.
Okay, great.
So let me go back to here. And let me just show this real quick so folks can see how we do this test, because this test is a little goofy. And let me just do this. So what we have here is our Nano VNA, and you can't do this on a Rig Expert, Doug and Don. And so Chuck, we're going to send a signal out channel 0, and it's going to come in through here, and it's going to go out into our first unknown. And it's going to go in here, and then we have our antennas connected together, and then we have our grounds connected together. And signal is going to come through the second one. It's going to come in through here, and it's going to go into channel 1. Now, because we're using 2 cores, we have to take our efficiency measurement, and then we divide it by 2, and that's going to tell us the percent efficiency of the core. I'm the same way, Doug. And so I wanted to just show this so people can understand how the test is configured. And then let me go back over to here. And let me go eye in the sky. I name all my stuff very creative stuff. It should be showing that, but it's not. Give me one second here. Just give me 1 second here. It's always something. It's always something. Or you probably see my calculator right now, and that's not what I want you to see.
Yep, that's what we see. Don's already complaining that it's too small to see it. So.
All right, give me 1 second here, guys. Jesus Christ, this is confusing. I'm sorry. Let me get out of studio mode and see if that makes a difference. I'm getting there.
The Smokin Ape will be played by the.
We're getting there.
Oh, I'm hearing complaints out there.
Well, I mean, it happens. Like, for some reason, it is not giving me the option to select.
What were you trying to select?
I'm trying to select.
Hey, Rob.
The Nano VNA.
Oh, Don says it's the text on the Nano VNA that's too small. It is pretty small. I think Ape has a bigger screen also than this one.
All right, I think we're going to be in business, boys.
Here we go.
Apologies for being a dingbat. All right, so can we?
Oh, look at that! It's huge now.
All right.
All right, so we had up earlier though.
Okay, so here's Nano VNA Saver, and what I need to do is I need to go into Nano VNA Saver, and I need to set this to an S21 gain measurement, and that will allow us. Let me just go ahead and run the sweep. Okay, so this tells us our loss as we go across from 6.5 megahertz up to 30 megahertz. And so you can see, if we take a look at marker number 1, which is in the 40 meter band, this is showing us our S21 gain is negative 1.334 dB. And that's also our lowest point of efficiency, right? And what I want to do now is I want to open up my calculator. So let me go over here and turn the calculator on. Can you guys see the calculator?
Yeah. Yes,
all right. So if I take 1.33 and I divide it by 2, we talked about why we do that, because we have 2 cores. So in the first core, we're losing 0.665 of a decibel, of a dB, right? So what we want to do now is this is where it gets a little tricky. I take negative 0.665, divide that by 10, close my parentheses, and then do a 10 log. So at its lowest point, it's 85.8% efficient, which isn't bad. So when you take a look at 9 to 1s and 49 to 1s, they're all in like 49 to 1 sometimes are even lower, but that's right in the area that you want to be, right?
In the range.
So let's just say you're operating 50 watts and you multiply that by 0.858. So 50 watts in, you're going to get 42.9 out. So that's how we calculate efficiency and figure out how that stuff works.
Mm-hmm.
And then here I am back. Now the efficiency only goes up from 85 and it goes as high as 87. It's around 87.8 in the 10 meter band. So I'm not going to spend a whole lot of time running through all that, but boring everybody to tears with the math. But that's
yeah.
That's how we get that.
We were pleasantly happy with Ape was a little worried about the efficiency part of that whole thing, and it turned out to be about what we wanted.
Yes. So, but the first couple times I did the efficiency test, that we weren't getting good numbers, but it's because I didn't have the solder connection correct, and then so once I got it fixed and started doing it, I was like, oh my gosh, thank goodness, because we went out and we bought 50 some cores, right? And I was like. And the cores
already tested it, so I knew they worked.
Yeah, their cores aren't expensive, but they're not cheap, right? So 50, we buy 55 of them.
Something like
it was enough of an investment where I was like, shit, I need to make sure I get the test right.
I talk about Mike, and he shows up into MAK. Mike has used the Rybakoff a lot.
He sure has,
and so it's been a popular antenna here recently. Kind of a resurgence. It's an old antenna. And like we said before, all these antennas have been around for years. So, and the other ones have been more popular. So we didn't do we did do testing, but we didn't have a show. We just thought of this the other night.
So we got a question here. How long is the antenna? So we're talking about a 25-foot element.
Mm-hmm.
Now the thing is that does change when you use things like velocity factor, depending upon the insulator on the jacket of the wire, and if you're using stranded copper or you're using copper clad aluminum or copper clad stainless or stainless steel or just pure aluminum. So it can change a little bit. Yeah.
So I'm going to do a little testing, I think this week, down at Quartz Fest. They also talk about adding an extra 25-foot section, for the lower bands. It will tune up. He didn't test 80, but I think it'll tune up 80 also for me at home here. I've never talked to anybody on 80. It seems like I just never, there wasn't a lot of people around when I was testing it. So, 80s at night, and I don't.
Yeah, so I worry a little bit about how well the core will transform 4-to-1 at 80. And the other thing is that when you get lower and lower, 80 is not as much of a problem as 160. But when you get to the lower frequencies, you create tremendous amount of heat in the core. And so that's a little bit of a challenge that we have there. I think that was everything that we were going to show on the.
I think so. Yeah.
On the course. So if anybody had any other questions there,
if you guys have any questions on this at all, and we're looking somewhere around the first week of February, probably be able to put these out.
Yeah, like I said,
it's going to go to the people we have our chats with for the what do you call it?
Supporters.
Oh, the supporters group's going to get first shot at them. And like I said, I think we're only going to do probably about 40-ish.
Well, we have
47, 48, something like that.
We have about 100, right? 100 frames. And so we have 50 green toroids. So that's 50 of those. And then 25 9-to-1s and 25 49 to 1s will be what is the next release.
Yeah, I think we're about due to probably order winders again here pretty quick.
They're all priced the same, Liberty, and there'll be a discount for supporters though.
It's basically all the same parts. I mean, this one's very close to the Apollo, I think. Oh, the
I
nine.
thought it was
No, it's
closer to
really close.
the Aries.
Yeah, parts wise, it has a few more. I forget a few more parts to it than some of them, but they're all about the same in parts and stuff. The winders is the same, so there's no difference there. The cores are all about the same price.
So, Mike, that's a good question. So, like, here's the thing, and we're not hating on anybody, but so we use a 16 gauge wire on our 49-to-1, and the reason we do is because we found that to perform the best for us. And we've had every expert on YouTube. Why do you use this gauge wire? You should be using blah, blah, blah. And we're like, well, this is the one that we've used, and it works great for us. And this is the one we've used, and it works great for everybody who's given us feedback.
Right.
And then for this one, we went with an 18 gauge enamel wire. On our 9-to-1, we use an 18 gauge PVC insulated wire. So it really depends on what we see best in testing. And I mentioned a little bit about the number of windings and how that affects efficiency. And that's another one. So again, the internet experts came out and they're like, well, why do you use that many windings on your Aries 9-to-1? And the thing is that it wasn't. Some of the folks
we did just pick a number. We did just pick
some of the folks asked us respectfully, but some of the other folks immediately come at you like you, I don't know, like you're standing too close in the elevator or something. And so I mean, when everybody asked me, I was like, why wouldn't I? Right? Because I want to hear what their answers are, and it always comes back to efficiency. So we did a shitload of efficiency tests. We test everything from 5 windings to 9 windings. Now you could make an argument that 7 is the best number there, but what we're really more concerned about is that controlling the core temperature, and we didn't see an efficiency loss of any notable portion. And we also want to maintain the impedance transformation ratio. So it's a lot of talk and answer your question, Mike. And I love the question because it's something that we spend a lot of time. I know that I personally drive everybody nuts because I'm even like, well, Chuck, why is that wire red and that one's not? I ask a million questions.
Yeah. And like I said, we started with. I was confused on the amount of windings because I was thinking that each double one they were talking like 16 windings and stuff, and Ape's like, no, you're doubling them. So if you have 8, you have 16.
16.
Because I'm like, there is no way these guys are getting that many winds on these things.
Yes.
So we started with what, 12 or 14 winds, I think, and just worked our way back until we found what worked good.
It was stuffed. It had so many.
I wonder if I still have a picture of that.
The red wire is faster. But the other thing is that so RF travels on the outside of the wire. So the larger diameter wire you have, the more opportunity you have for current to pass. Also, you have to take a look at wire, and smaller wire sometimes gets hotter with high energy going through that wire. And so it's not so much the core gets hot and saturates, hits a Curie temperature, and you lose magnetic transformation. It's that the wire gets hot, and then you can have structural integrity problems with the wire. So we like big porky wire. What can I say on the cores? And that's what we found to work for us. And then we use a silicon jacketed wire for the ground elements and for the antenna. And again, people gave us a ton of grief about that. Like, why are you using that wire? One, we like it because it's tangle free. That's probably the biggest one. We also like that it has a high velocity factor on it. So it's just a result of the testing that we do, Mike.
Yeah, it's been really good. Oh,
thank you, Mike. Much appreciated. I suppose I got to push one of these buttons, and let's do. Oops, I got a little happy there.
Yeah, Hamstick Eric's he's talking when people ask, just telling him that he runs an Aries on 160.
Yeah, so our buddy Gray Man Tim is asking about the bandpass filters. Wait till you see what we have coming out. Well, not we. So I was talking to that guy Ben that we had on Ham Radio Rookie, and he was able to put together some sweet phenolic PCB boards for bandpass filters for me. I mean, they're incredible. Nice. Like I like jaw on the floor. So that'll be coming out. That's cool. And then we got Jeff's always posting pretty informed stuff here. He says, core temp is more critical than efficiency. If you saturate the core, the system won't work. I totally agree with you.
Yeah.
But this one, you have to go efficiency to keep your cores working at higher power. Totally agree.
And this is like 100-watt radio, 100-watt antenna, guys. That's what we're saying. 100 and probably 50. I'll test it this week on some FT8.
So it looks like Vern's coming out
or
with filters. I don't know. I have no idea if he is.
Oh, I don't know.
I have no idea.
No, I don't either.
I'm not sure when Winterfield Day is, Gray Man, but we'll figure something out.
It's usually the week after Quartz Fest or something. It's pretty close to it. So 2 weeks, roughly. It's on the weekend, isn't it?
That might be a tough order.
PCB way. I haven't even heard about that story, guys. So that's a new one to me.
Which one? The saturated pants?
No, the filters.
Oh. Yeah, man, I got to tell you, that guy Ben, that guy is smart, and he is super talented. So if you haven't seen it, when we had Ham Radio Rookie on Coffee and Ham Radios, that guy was fantastic. And then like right after the show, he shoots me an email and he's like, "Hey man, I can help you do X, Y, and Z." And I'm like, deal.
Nice.
Yeah. So we're actually going to do a build video and all that stuff of them. So I'm pretty excited about that.
Sean said the 28th and the 29th, he thinks.
I don't know, Gray Man. I'll reach out to you and tell you how, but you might be up the creek.
Well, we hope this is pretty educational. Hopefully, I don't know. Ape does a good job with this stuff, and just happened to be my night to do this. But we're trying to do this every couple of weeks, something. It's a little more technical than we usually do. I mean, you guys, if you're not doing anything, you got a bunch of hours to watch. Watch our DMR video on TO's thing the other night. Oh my god! I told my wife I got a headache. Don't bother.
What was funny is that after Hallmark night, I went on YouTube to see what it was doing, and you guys were still streaming. I'm like, oh my god, they're still going.
You know, it was weird when I unplugged the thing. It like totally did what it was supposed to do. I don't know what it was. Kind of weird. It wasn't hooked to anything, and I don't. It's almost like it was delayed inside the radio someplace. I still have to do a little video on that radios too, and we were hoping it was going to go better like that at night. But we got anything else tonight? Oh, it was painful. Kathy says. Yes.
Yeah, Mark's saying he needs to figure out DMR. He's got an Anytone 878. I've got the BTEC DMR 6X2, which is the exact same radio, and I have a ton of videos on how to work that radio if you want to check them out.
Yeah, that's when if you're going to buy a DMR, that's when he says to get.
Yeah, next Wednesday.
Oh yeah,
Jim and I are going to do a deep dive of coax testing next week.
Deep dive. All right. We got anything else? So, like I said, somewhere around the first week or so of
we got about March, 2 weeks
or February. Excuse me, February.
About 2 weeks.
Well, that's all on whether I can make kits by that time too. So
we're waiting on we ordered 5.5 miles of wire, so we're waiting for that to arrive.
Yeah. We have a few antennas left too of all the other ones right now, guys. About 3 of each, I think. We're down our wires late getting here, so what do they call that?
Probably it'll be a Hamcation announcement, the big announcement of Hamcation. Yeah. See if we can get it on the billboard.
That's right. It'll be get your.
All right. Well, I think that's it. I'm gonna push the button.
Thanks, all right, everybody. Thanks for being here. Thanks for enduring with us.
Much appreciated.
Yeah.